Okay, so question 5 is asking us to sketch a graph of f with the following rule. We've got to label the intercepts of the axes and endpoints, and it's important that we do that with their coordinates. Okay. So the first thing I reckon we want to tackle is perhaps this domain restriction, because that's going to be really important. So I'm going to put a big red line down the x equals 0 and the x equals 5 line. So we're going to chop off everything that's outside there, but we are going to include those values because of this square bracket. So these are included. So we're going to use colored in dots. Alright, so just to get a feel of what the graph's going to look like, just over here, let's just do a rough little sketch of what we might expect. So the modulus of x minus 3 would look like that. Now, we reflect it, so it's going to look like that. That's what this negative sign is going to do. And then we raise it up 2 values. So it should look something like that red graph. Then we just cut it off at x equals 0 and x equals 5. So just roughly, if we looked at the x equals 0 case, we would get negative of the modulus of minus 3 plus 2, which is just negative 3 plus 2 equals negative 1. So that's going to be the coloured in dot along that first line there. So that's one endpoint, and we're going to label his coordinates as being 0, negative 1. Then let's test out the x equals 5 case. So this is going to leave us with, so the negative of 5 minus 3 is minus 2 plus 2. So that's going to be negative 2 plus 2 equals 0. So we can put in on the next red line there, if I just remove him, our next endpoint at 5, 0. And then remember this apex here, this little vertex, occurred at x equals 3. So let's evaluate the x equals 3 case. So that one's going to be the negative, so 3 minus 3 is 0 plus 2. So that's just going to be 2. So at x equals 3, got the point at 2. So this is 3, 2. And we can just connect these up using a ruler in the exam, but I don't really have the ability to use one on here. And then the last thing is just the x-intercept that occurs when y equals 0. So when y equals 0, we have 0 equals negative modulus of x minus 3 plus 2. Now we know we're on this line I've just aimed the green arrow at there. And that's going to be essentially positive x minus 3. So we're going to be at negative positive x minus 3 plus 2. So now we have forgotten the modulus function. So subtracting 2 across, we get negative 2 equals negative x minus 3. And then plussing 3 across, so we get 1 equals negative x. Therefore, that's going to be expanded plus 3. So we're going to minus 3 from both sides. We're going to get minus 5 equals minus x. So x equals 5 as one of the intercepts. Oops, sorry, I found that. That's that side of it. And then the other one would occur when the graph is 0 equals negative of negative x plus 3 plus 2, and then we subtract 2, so negative 2 equals negative, okay, let's expand this negative out, so plus x minus 3, plus 3 to both sides, and we get x equals 1. So That last point in there, which I'll do in this, might do it in red so you can see where I'm going for that one. That one's going to be x is 1, y is 0. So there we've got our two x-intercepts. One of them happens to be at an endpoint as well. Alright, so that question was done fairly well, with 46% of kids getting full marks and the average being about 2 out of 3. Alright, so we've done that part up there, and I don't actually think it has any effect on B, so I'll just scribble it out. So we want to find the coordinates, so an x, y coordinate of the image of the point 2, 3 under reflection in the x-axis, followed by translation of 5 units in the positive direction of the x-axis. So if we just sort of sketch out where it sits to start with, this point here, 3, 2, is at the point 3, 2, so it's here. So we reflect firstly in the x-axis, so this just means that this is going to be now 3, -2, followed by a translation of 5 units in the positive direction of the x-axis. So we're just going to move him 1, 2, 3, 4, 5 to the point that is going to be 8, -2. So our image is going to be x, y is equal to 8, -2. Okay, so part 2 actually asks us to use this f equation here. So we're going to be asked to find the equation of the graph of f under reflection firstly in the x-axis, followed by a translation of 5 units in the positive direction of the x-axis. So again, let's just start from our function f. Our first thing is we're going to reflect it, where we need a negative out the front, and the next thing is if we want to move in the positive direction, we're going to need to use an x minus 5 in the bracket. So if we sub this into the f equation up here, we're going to get that this is the same as, so negative x minus 5 minus 3 plus 2 equals positive x minus 8 plus 2. So the new f2 maybe, whatever you want to call it, of x is the modulus of x minus 8 plus 2.